Hi, welcome back to Imperium Learning. This is the second video in a video series about estimating and interpreting a vector error correction model. I'm still on showing you how to detrend a trend stationary process so that we can include it as an exogenous variable in our vector error correction model. So just carrying on from where we ended in the previous video, you can see that I've selected the least squares with breakpoints method for our estimation settings. And again, what I'm going to do now is I'm going to type in learn GDP, and remember we've got two boxes here, and we've got the dependent variable. We're going to say that there's a break in the constant or a break in the intercept, whatever you want to say, and then there's also a break in the time trend, and we're going to put dummy in here, right? We're going to put that in there, and we're going to go to here, and as you can see, now for me personally, I used the Chow test already to find the structural break date, and we chose it as March of 2008. So as a result, I'm just going to specify it like so, and I'm just going to click OK. Now we want to look at the residual graph again of this equation, because ideally we want it to regularly cross the 0 point on the y-axis, and it really should never swing too far away from the 0 point on the y-axis. So let's take a look at the residual graph now. Now that's a lot more encouraging. If you remember in the previous video, the y-axis was going up to 0.12, and I can't remember what it was going onto on the negative side, but as you can see now, it's a lot closer to 0. It crosses it more regularly, and as you can see, most of I'd say a majority of these points are within 0.01 and minus 0.01. That's much better than what we had in the previous time, with just estimating a least squares regression. And so based on that, I think that's probably the best we're going to get. Unfortunately, we still have this kind of structural break, but it's nowhere near as big. How far it diverges away from the 0 point on the y-axis. So that was personally the best that I could get. And so as a result, I'm going to save this residual series. So the question then is, how do I save a residual series based on the equation that I just estimated? All you have to do is go up here and click on proc, and then you click on make residual series. So I've already just estimated this. I'm going to call it GDP Res 2, and I'm going to click OK. Yes, I want to replace it. Now I've already got a GDP Res. This was the exact residual series that I used in my dissertation. Let me just graph this very quickly to see if it's the no, actually it's a little bit different. It's a little bit. Wait, let me just graph these together. Okay, view, graph. Okay, they're actually close that. They're actually slightly different. they're actually slightly different. You can see particularly around that structural break date, that's probably a result of having a dummy variable that was coded slightly differently. But as you can see, most of the other points that are both before and after the structural break sort of align with each other. So I think that just takes a little bit of fine-tuning to reprogram the dummy. I'm not going to do that right now though. I'm now going to be showing you how to estimate the vector error correction model. So we click on Quick, click on Estimate VAR, select the vector error correction model, and now what we're going to do is we're going to, in the endogenous variables box, we're going to first type our desired dependent variable. Now, I was investigating the macroeconomic determinants of house prices in the UK, and so this is my average house price variable there, so I'm putting that first. I'm putting the money supply second, credit fourth, interest rate fifth, the unemployment rate last. And in the exogenous variables box, what I'm going to do is I'm going to put my GDP residual series in. But here's the thing, in order to keep it consistent with my lag length for my vector error correction model, I found that in a previous video that it was 2. I'm going to put in 2 lags of my residual series, and that's how you write it. By the way, you put in your variable. I'm choosing GDP res, and then I'm going to put in brackets -1. That means it's the first lag of the GDP residual series. -2 means the second lag of the GDP residual series. After that, I'm going to click on the co-integration tab. I'm going to make sure that the number of co-integration relations is the same as what I concluded in the previous video. It's 1, and the assumptions is 3. That's what I found when I was doing my Johansson test. So make sure that your vector error correction model aligns with what you found after you conducted your co-integration test, and we're just going to click OK. Now I want to move on to interpreting these vector error correction estimates. So going back to my PowerPoint very quickly, there are certain things that you should really be looking at. The first thing you have to look at is your co-integration vector itself. You need to be looking at the signs of the long run relationship, and then on top of that you need to be looking at the sign and the magnitude of the coefficient in front of the co-integrating vector. Okay, so let's just let's see what my my additional slides are. So let's just go back to Eviews very quickly. As you can see, I have actually I can see right now that I'm again approaching the 10-minute mark. So what I'm going to do is I'm going to wrap up the video now, and I'm going to record a third video which really goes into analyzing all the variables and how they relate to each other. So I'll wrap up the video now. Okay, bye now.